Okay, last chapter. Chapter 14, exponentials and logarithms. I've just drawn on here the basic shapes of the y equals e to the power of x and y equals e to the power of minus x. So just remember there's an asymptote at y equals 0 for both of those, and the rest of this is just a transformation. Even the minus x is a transformation where it's flipped in the y-axis. So plus 1 means it's all going to go up 1, including the asymptote. If you times it by 4, then all the y coordinates are going to times by 4. So that's going to go up from 1 to 4. And then the 2x there means all the x coordinates can be divided by 2. So it's going to be this graph, because it's a minus 2x squished, which really has no effect on your sketch. But the number there is going to be 4 times bigger. If you've got more than one thing happening, just do it in BIDMAS order. If it's happening to the y coordinates, so times by 2, then take away 3. And if there's more than one thing happening to the there's none of these have more than one thing happening, but you do it in the reverse order. Just apply one at a time if you want to, because there's 3 things happening here. The x coordinates are doubling, then the y coordinates are timesing by 10 and adding 6. So I'll just do that one e, because it's got quite a lot happening, just as an idea. So first thing that happens, all the x coordinates are going to double. That has no effect on the sketch. It's just going to affect the scale, but because it's not crossing the axes or anything, or the x-axis, then it's not really going to have any effect. It's going to times by 10, so instead of going through 1, it's going to go through 10. But again, nothing on the scale is going to matter. And then the plus 6, that's going to affect where the asymptote is. So instead of y equals 0, it's going to be y equals 6. That's 6, and then it's 10 higher than that for where it crosses. So you see it's basically the same shape. This is 6, that's 16. It's not going to cross any other axes, and it's got the same shape as a general exponential shape. Differentiating e is pretty simple. E to the power of kx differentiates to k e to the kx. So the actual e to the kx bit doesn't change. All you do is multiply by the constant that's in front of the x. So a is going to be 6e to the 6x. B is going to be minus a third e to the minus a third x. You get the point. I'll do f because it's a little bit different from the others. So e to the x times e to the x is e to the power of x squared, which is e to the power of 2x, plus e to the power of x, and then that will differentiate to 2e to the 2x plus e to the x. So all we had to do there was use that index law, e to the power of x squared is e to the power of 2x. Finding the gradient of the curve at the point where x equals 2. I mean, it's differentiate this, so the gradient function is 3e to the 3x, and then you just substitute in x equals 2, x equals 0, and x equals negative a half. Okay, no more difficult than that. Rewriting using a logarithm. This is the base, this is the power, and then I'll call this the answer. So when you rewrite that, you've got this, if I call this a to the power of n equals b, then that gets rewritten as log base a of b equals n. Okay, so that means that this is the base, that is the power, and this is the answer, if that's what you want to call those things. So 4 to the power of 4 equals 256. If I want to rewrite that, I wrote log base 4 of 256 equals 4. It's not a very good question because it's got 2 4s in it. So let's just do one more. Let's do e 0.2 is going to be my base, so log base 0.2 of the 0.008 equals 3. Okay, you can always check those at this stage because there's no so as long as that comes out to be fine, or the same number that you've got here, then you're okay. Okay, so it's just rearranging, and this is very useful, especially going this way, because a lot of the time when you're solving a logarithmic equation, you end up with log of something equals something, and you want to solve that. To solve it, you write it in the exponential form and then solve it. So rewrite using a power goes the other way around. 2 to the power of 4 equals 16. As long as you know how to rearrange it, as I say, same thing again, a to the power of n equals b becomes log of base a of b, no, of n, sorry. No, of b equals n is how you rearrange that. The a is the base, n is the power, b is what I called the answer earlier. Cool. Writing something as a single logarithm is the first step when solving logarithmic equations. That's what we're kind of like heading up to. If you're adding two logs together and they have the same base, and then neither of them have a coefficient, then you can just multiply 7 times 3, 21. Okay, if you're subtracting, that's the log law. If it says subtract, same rules. You have the same base and no coefficients, but you can then just divide. If you've got a coefficient, that has to go first. So that is the power law. Make it a power. Log base 5 of 2 to the power of 3. And then this one, log base 5 of 10. They've got the same base now, and neither of them have a coefficient. They've both got a coefficient of 1. So that is log base 5 of 80. This is 2 cubed is 8. And then instead of add, you times the bits inside the, I didn't write any brackets, but the bits inside the brackets, the thing that's having the log taken of it, that's 8 times 10, 80. Again, if you're just doing that simplification, you can check by putting in this, seeing what number it says, and then putting in this and making sure it's the same number. Always make sure to do, it's still BIDMAS, I suppose. If it says 3 times something plus that, you do the multiplication first and then you do the addition. But multiplication becomes a power and addition becomes multiplication, but it's still in the same order. Yeah, these ones now say simplify, but it's going to be the same sort of idea. Just do the first one to show you. You're doing 40 divided by 5, and that is 3 because 2 to the power of 3 is 8. You can use a calculator to check them, but I would try and do it in your head because it gives you an understanding that you don't get by just putting it into a calculator. You do see questions a bit like this sometimes in exams, where it asks you to write it in terms of log x, log y and log z. What normally they will do is they'll call this, I don't know, p, and they'll call this q, and they'll call this r, and then they'll ask you to write it in terms of p, q and r. No, it doesn't really change the question. This is going to be log base a of x cubed plus log base a of y to the 4 plus log base a of z, which is 3 log base a of x plus 4 log base a of y plus log base a of z. If there was one, if it was asking you to write it in terms of p, q and r, then you would just make that 3p plus 4q plus r. This is very commonly what they do in exams. They'll call something p and then ask you to write it in terms of p. All I did there was I split them. I couldn't do the power law first because they didn't have the same power. So I wrote them as 3 separate logs, and then I brought the power down. So times 3 by log base a of x is the same as log base a of x cubed. It's the power law. Intermediate brings us on to solving log equations. It's just doing the simplification thing from these questions, followed by solving. So instead of it just being numbers, there's an x, but you combine them together. You're aiming for a single log equals a number. And if you get to a point where you've just got the word log once and everything else it looks like this, so you've got log base something of something equals a number, that's what you want to get to. Once you get there, you use the rearranging understanding of how to rearrange logs to get it into an exponential. So that would become 2 to the power of 2 equals 3x. Yeah, so that's the base, that's the power, that's the answer. And then solve that. And if you've got, like this one, something a little bit more awkward, let's do that one as well. I would put them on the same side, so the log's on the same side, just like you would if you were solving a normal equation. Before you combine them together, you've got to get rid of this coefficient, so that you can then do your division. So subtraction becomes division. And then once we've actually combined all of the logs together, so we've got one log, something inside the brackets, and a number on the outside, I could just do 5 to the power of 1 equals x squared over 6. So that means x squared is 30 and x is square root of 30. Okay, be careful with logs because you can't put negative numbers into logs. You try and take the log of a negative number or even log of 0. So it's fine when it's 1, but log of 0 is not allowed, and log of -1 is also not allowed. So it's not positive or negative 30, it's just positive. It's not positive or negative root 30, it's just positive root 30. If you want to check your answer to see, I'd just go back. What was my answer? Root 30. So 2 log base 5 of root 30. That's right, take away log base 5 of 6. Should be equal to 1. You didn't see all that. But put it back in and check that it adds up. So I did that one. Take away log base 5 of 6 and it did equal 1. Solving equations like this, if there's only one exponent, so like 2 to the power of x, 7 to the power of 2x minus 1, there's just the one exponent, you just use log base 2 on both sides. Okay, so if the exponent is 2, so not the exponent, the base is 2, use log base 2. If the base is 3, use log base 3. If the base is 7, use log base 7. Because then they cancel. Log base 2 of 2 to the x is simply x. And you've got a solution there. Log base 2 of 75. It says to give it to 3 significant figures, so that's 6.23. And you can always check with any solving equations. 2 to the power of 6.23. It's rounded, but 75. With these questions, we've got pseudo-quadratic equations. So if you've got power of 2x and then a power of x and then a number, what you're looking at is a pseudo-quadratic because you've got a power, half that power, and then no power. So for a lot of people, what helps them out is just introducing a new variable. So y is 2 to the power of x, and then rewriting this as y squared minus, it doesn't look at all like y squared, y squared minus 6y plus 5 equals 0, and then solving this for y. So you get y minus 5, y minus 1 equals 0, so y is 5 or 1. And then once you've solved it for y, putting back in the exponent and then solving it. So this is going to be log base 2 of 5 or 0. Okay, so the way I recognise that is the double power, single power, and then no power. If you've got one of these slightly more awkward ones, remember just to use the index laws backwards. So I'll do E as well. Index laws backwards would be 7 to the power of x squared is 7 to the power of 2x plus 12 equals, and then this is 7 to the power of x times 7 to the power of 1, or just times 7. This is still a quadratic, so it's 7 to the power of x squared minus 7 lots of 7 to the power of x plus 12 equals 0, and then I would just solve that. You don't have to use this substitution, you can just solve it. Just remember that your answers aren't going to come out to be x, they are 7 to the power of x. So one of those, minus 7, 12, so 4 or 3, which means x is log base 7 of 4 or log base 7 of 3. Again, if you want to check them, you can. Just go in and write the equation to log base 7 of 4 plus 12, take away 7 to the power of log base 7. No, wait a second. What's x? Log base 7 of 4 plus 1. Okay, fine. That should come out to be 0 because I did that one take away that one, which means that if that one and that one are equal, then they one take away the other is 0. That should also be true if I put in log base 7 of 3. Oops. So obviously you can check your answers in the back of the book, but in an exam it's quite nice to see that you've got the right answer, you've checked it, and you've put it back into the original equation, it's come out to be correct. If you've got one of these questions where you've got two different bases, you just choose one to take logs of, and it doesn't really matter which one you choose. I'm going to take log base 5. Just do the same thing to both sides. You can't take log base 5 of one side and log base 2 of the other side. This side is going to it's going to simplify to just x, and then this one you're going to multiply the power down, so x plus 1 lots of log base 5 to the 2, log base 5 2. Log base 5 2 is just a number, like it's a third, but it's just a number, so you can expand it and put your x's on the same side. Done two things there in one. I've expanded it, so x times that and 1 times that, and I'll put the x on this side. Factorise out the x, and then divide. So that's the exact answer. It said to 4 decimal places. So 0.7565, and this again check it, you can put it back into the original. Do 5 to the power of that answer minus 2 to the power of that answer plus 1, and it comes out to be 0. Just did that one, take that one. Answer 0 means my answer's right. Okay, so it doesn't matter whether you take 5 as the base or 2 as the base, just do the same thing to both sides. Bring the power down, one of them will cancel. And then remember that log, as long as there's no letters in here, that's just a number. Okay, it's like having a root or sine of 23. You know, these are all just numbers. Root 2, just a number. Sine of 2, just a number. Okay, or log base 2 of 5, just a number. Okay, they're just written in a way that's exact. So if it says give your answer to 4 decimal places, you can always just write this one over here was log base 5 of 2. This is what it is as a number. You can just replace it if you want. Just use more than 4 decimal places. Use 5 or 6 decimal places, and then you've just got numbers and you can solve it. But the more mathematical approach would be to leave it in its exact form and then solve your equation like that. But if you know you're going to give your answer to decimal places, it doesn't really matter. The only thing that's new here is ln and e. So ln is the same as the logarithm as base e. So if you want to solve this equation, all you would do is do e to the power of 2 equals ax minus 3. It's the same as before. You've got a single log of something equals a number. So the power is 2, the base is e in this case, and then that's the answer. That is pseudo-quadratic because it's got the power of 10x to the power of 5x and then no power. So here, if you wanted to do a substitution, e to the power of 5x would be that substitution. But it's just going to be solved like a normal quadratic. Here, I would just square root that before. Don't try and expand it. Square root it, get plus or minus 4. Some of your answers might not be true. Solve them all, put the values back in, and anything where x comes out to be negative, you know, is just not correct. The last thing is models, either exponential models or making straight lines out of things which are not straight lines. Let's talk about exponential models first. That's a t up there. Otherwise there's no variable. So the value of a car is modelled by this formula. When new, that means when t equals 0. It's age in years. If it's 0 years old, it's new. So that would just be 20,000, because it's 20,000 times by e to the power of 0. E to the power of 0 is 1. Find the value after 4 years. With any model, if it tells you a number, you're going to substitute that number in and solve. Okay, so this one's nice and easy. This is put in t as 4, just put it in your calculator, press equals, that's going to be the value. To sketch it, if it's got a positive, then it's going to go up. This one's negative, so it's going to go down. Be aware that sometimes there's a plus something, so there's an asymptote, but here there's no plus, so the asymptote is 0, and the initial value we already know is 20,000. That's it. You're going to see the same things repeated over and over again. There's a plus 20 at the start, which means that when you do your sketch, it's going to start at, also it's going to have an asymptote at 20 is y, it's not y, it's p, and then this is going to be 21. And because it's got a positive power, that means it's going to go up. Okay, the rest of the time, state the population in year 2000. You just put in t equals 0. Oh, it's got a 10 there, sorry, so that's 30. It's going to be 30,000 because population is in thousands. Use the model to predict the population in the year 2030. If it gives you a number, you're going to put that number in. So here t is going to be 30 because t is the number of years after 2000, so 2030 is 30 years after 2000, so put in t equals 30. Sketch the graph, that's over here. And do you think that it would be valid to use this model to predict the population in the year 2500? Again, it gives you a number. Put that number, in this case 500, in, and it'll probably come out to be ridiculous. But just do it. Put the number in. Where's e on this new calculator? There it is, to the power of 10, because it's 500 over 50. That's not too ridiculous. Oh, wait a second. It's in thousands. So that is 220,000, so 220 million. I mean, that is a reasonable population for a country. Is that reasonable population for a country that was only 30,000? I don't know, it's 500 years later. You have to make your decision. I would say work out what the answer is. So put in the value of 500. It's t. Work out the number. So that's 220 million. Say there are countries where it's 220 million, so it is possible. Or that's a ridiculous size for a population of a country, so no. But if you've got the number and you're basing it off that, then you know, you're more than likely going to get the marks if you've got some numbers to back it up. I would say probably it's not, because I don't think there's any population model that we can use to predict the population of something 500 years in the future, but that's up to you. Yeah, similar thing. This one's got a negative power. It's got 300 as it's going to start at 300 minus 100. Which is 200. I'm just trying to work out whether the asymptote will be, I mean, I'm just looking at it, I'm not really thinking, but if you ever do want to know where the asymptote is, all you got to do is put in a very large number for t. So to the power of minus 0.5 times, and let's just put in, I don't know what that is, like a trillion. So 300. What about when it's 0? 200. Which means it's going up. Are we taking away something with a negative? So let's just put the asymptote at y equals 300, or n, sorry. And then it starts at 200. So it's going to do this. That's less obvious what's going on, but hopefully you saw what I did. Put in t equals 0 and you get your initial value. Put in t equals a very, very large number and you get what your asymptote is. Okay, and then you can sketch it based on those two pieces of information. How many people were first diagnosed? 200. What is the long-term prediction for how this disease will spread? It will grow and then it will level out at 300 people. So it's gonna stop because it's the time in years and it's the total number of people. It's not the number of people per year, it's the total number of people who've been infected. So it's going to decrease in the amount that it's being spread, and will end up being no spread with a total number of people of 300. Right, the last thing then, I think I said that already, but is using logs to make things which are not straight lines into straight lines. So this is not obviously not a straight line, it's got x as a power, it's going to be an exponential graph, but you can change these into something that looks like a straight line by using logs. So the way that you do that is start with this and then take logs of both sides. If it ever says log like that, it's log base 10. If it doesn't say a number, it's log base 10. So when you take logs of the whole left-hand side and the whole right-hand side. Okay. Then split this up by using your log laws backwards. And then bring down the power. And then, well, actually we've got it in that form already. The straight line graph of log s against x is plotted right down the gradient. So the reason we've got it into this form is because now it looks like y equals, this is m, because that is times by x plus c. Okay, so the value of the intercept, log 4, on the vertical axis, the y-intercept, and the gradient, log 7. And this is kind of repeated for all of these questions. The first thing with a lot of these questions that you're going to do is make the equation n equals ab to the power of t, which may not look like this one, but it's exactly the same. It's a number, sorry, a variable equals number times number to a power of a variable. So variable 1, that's the y variable, equals number times number to the power of another variable, it's the x variable. And when we do it on this, we've got n equals ab to the t, n is the variable, equals number times number to the power of another variable, which is t, that's going to be on the x-axis. It's exactly the same. So the first thing, write down the equation for the line, that's chapter 5, using your answer to part A, or otherwise find the value of a and b. So you've got, in this case, you're going to know the y-intercept of 1.6, and you're going to know the gradient by doing, what is it, 2.55 take 1.6, so 0.95 divided by 10, 0.095, that's the gradient. And then what I would do is each time I do this, take logs of both sides, log base 10. Remember to split these apart first using, because the t, the only b is to the power of t, so you can't bring the t down yet. You've got to split the a and the b to the t from each other before you can bring the t down. So log a plus log b to the t, and now you can bring the t down. And now it's, that is your y-axis, t is your x-axis. So that's your gradient. No, sorry, the gradient is the one that's times by x, that's your gradient, and that's your c. Right, so you want to find out what a and b are. Let's just do the y-intercept. That's log base 10 of a equals c. I told you that was 1.6, you can see that on the graph. Y-intercept 1.6. 10 to the power of 1.6 is going to be a. So 39.81. Oh, it says given to two significant figures. So 40. Do the same thing for the gradient. So you're going to get log base 10 of b equals the gradient. What did I say that was? 0.095. If that's correct. I did that in my head, so it might be wrong. But b is going to be 10 to the power of that. So just put that in your calculator. 1.24. It says two significant figures, so just 1.2. And then interpret the meaning of the a. So let's write the equation again. N equals a times by b to the power of t. So a, that's when t equals 0. So I don't know what it was. It's a number of people who have fallen sick with a virus after t days. So that is on day 0. That's 40 people who are sick. use a model to predict the number of sick people to the nearest 100 after 30 days, you just put in t equals 30. I was expecting it to say what's the meaning of the value b, in which case I would say that it's a 20% increase each day in the number of people that are sick. If you remember back to COVID, I don't know if you were watching the news and paying attention, there was a thing called the R value, or the R, I can't remember what they called it, but if it was more than 1, then the virus was spreading exponentially, and if it was less than 1, then it was getting better, it was getting fewer. This is essentially that R. If that number there is more than 1, then as you increase t, it's going to get bigger and bigger and bigger, the n. If this number is less than 1, then it's going to get smaller and smaller and smaller. Okay, and it's an exponential growth or an exponential decay, depending on whether that number is more than 1 or less than 1. So, cool. There's a lot of questions that are similar to that, including the ones in the exam questions. But I think I've covered everything that could come up, and all the other ones are just kind of related to it. I do just want to do one of these questions with a p in it. So here is what I was talking about earlier. It said p is log base 3 of x. So write this in terms of p. You just write it as log base 3 of x minus log base 3 of 9, which is log base 3 of x is what they've called p, and log base 3 of 9 is 2. This is log base 3 of x to the power of a half, which is half of log base 3 of x, which is half p. So it's only 2 marks, but there's a few questions like that amongst these. Then it goes on hence or otherwise solve this. I would always go with hence. So 2 of that one, so that's 2 of this, plus 3 of the other one, so plus 3 of this, equals minus 11. Literally just expand that. It's a linear equation. Solve it. Okay, I think that'll be it. There's again plenty of questions. They do get pretty difficult towards the end, especially these ones. I think once you've got your head around these, it's okay. And if you don't know where to start, always start by taking log base 10 of the equation that they've given you. Same thing here. You've got the equation there. Find the complete equation. Start by taking logs. If you don't finish, at least you've got some marks. Okay, and that is that. Enjoy.